in today's session, we're going to relook at microservices. We looked for many years, but now we just go back and turn around and to relook. I'm Emily Jiang from IBM. Yeah, I'm one of the Java champions, and I work on open source projects, Microprofile, Jakarta EE, and also the implementation. One of the implementations is Open Liberty, which I'm very passionate about. I'm the cloud native architect for IBM. I'm based at Hersley Lab in the UK. My Twitter handle is Emily FH Jiang. So if you have any questions, and afterwards, if I don't have time to answer your questions, reach out, and I will answer via the, Twitter messages and etc. So in today's session, I'm going to talk about the history of microservices and also the common myths and facts about microservices, and also if you are thinking to do microservices, talk about what kind of things you should know about microservices. Finally, I will touch on the future of microservices. Is microservice going to stay around for many years, or it might become obsolete soon? Let's have a look, have a pause and look behind what happened in the past a decade about microservices, and how microservices evolved in this decade, and where did it from originally. As first, do you all remember EJB? Anybody? EJB? Yeah. Actually, EJB is back in the 1997, IBM released the first version EJB. Do you know that? So I'm quite proud, and also is torn. So it's, EJB was evolved. Why is the kind of general? Why we IBM created this specification for EJB? So basically, it's trying to create a small component, reusable, and also is kind of the it's smaller, can be lifted and reused in the different environment. So this is the kind of the EJB. So basically, it's a module for enterprise applications. However, originally thinking, okay, we want to create a very simple architecture to reuse the business logic. However, but it's not very easy. It's very complicated. There's another thing is it's only suitable for Java. And when people are thinking about, okay, if I have multiple components, they need to talk to each other. It's not all the components are going to be written in Java. So with this, there's a new kind of desire. So how can we make this component written in different languages communicate with each other? So with that demand, that comes with the SOA, service-oriented architecture. So with the SOA, the SOA basically is, again, is the architecture model. So it's trying to establish a pattern, make these components to communicate each other. So the communicator root is known as SOAP. SOAP is a simple object access protocol. So basically, it's okay, this component can talk to each other via this protocol. This protocol is transferred between the component and the other component, between the components in XML. Again, when you talk about XML, you will feel like, oh, okay. It's even one character. You need to allot a boilerplate, right? Create XML format and etc. And then very soon, people fed up with it. So it's back in the early 2000. It's 2007 to 2008. So it's a computer industry fed up with SOAP. And then it's create a new thing. It's called REST, representational state transfer. So nowadays, I think, who knows REST? Who knows REST? Yes, very, very soon, like back in the 2009, quickly, within 2 years actually, REST is very, very popular. And then with the REST, you create like a REST API, like a get, put, post, all this kind of style to translating data and over HTTP. So this is REST. When you use REST to like a REST API to develop your application, this application is called a RESTful application. This who else knows the Jconf RESTful web services? Okay, so the Jconf RESTful web services basically is under like the Eclipse Foundation. This is the specification. Tell you exactly how can you do the RESTful microservices in a standard way. So if you do not know that, and I highly recommend it to check it out. So with this REST, like basically establish a pattern about a REST application. And then people, like it's quite a mouthful, right? REST application, and also you transfer data via HTTP, and this what kind of application is called? And then like in the 2011, 2012 period, and people say, okay, let's call it microservices. So this is like microservices. So this name become popular is around like 2012 period. And then with microservices, and then what about other applications? What about the applications like not microservices? And we need a new name. And then it's kind of back in like 20, 30 years ago, nobody called like say, oh, okay, I'm doing monoliths, but suddenly you are labeled like, oh, what you have been doing in the past 20 years is monoliths. So yes. So let's like look at monoliths. It is new things almost all the time. Like if new things comes out bad, like the older things become bad. So is that monolith old-fashioned, problematic, is it evil? So before we answer this question, let's look what is exactly microservices. So basically, microservices is just like testable and maintainable and independent deployable. This is very key. So like in the past, people ask me, okay, what is microservices? How many microservices do I need to create? Is that like one class is microservices? Is it two classes? Is it too big? So no. Actually, microservices is a division, like microservices is independently deployable. So these are microservices. And also it's loosely coupled. So between the microservices, there's a clear boundary. And your microservices do not need to rely on the other microservices to be able to function. And then the next one is microservices is kind of organized among business capabilities. So basically, the other thing is for microservices, you need to give me one sentence to tell you what does this microservice do. So it's basically have a clear meaning for that. Lastly, microservice should be managed by a small team. So if you have a giant 20-people team, that's too big for this microservice architecture. So if you have like 4 or 5 people, maybe it's kind of you manage a microservice, or 2 people manage a microservice. That sounds about right. So again, the other thing is also microservice is the kind of influence your org charts. So your organization, once you adopt a microservice, maybe sometimes you need to split your team size as well. let's look at the myth about microservice. So this is what I mentioned earlier, is that the smaller the better. Actually, this is a true story. Actually, someone came to me, actually it's quite high up. He said, I said, how many microservices do you have? He said, not many. I only have 20, but I aim to create 50. So I feel like he hasn't done macro profile right, because he hasn't got that big number of microservices. It's not about the size. It's not about the size. It's not about the number. You must clearly remember the thing is microservice is not about size, not about number. So it's about the business capabilities. The other thing is this is again is one person is is a manager, is trying to give a performance review. He said, this person, this developer is great. He creates 3 microservices. The other one only creates 1. So he's better performed. Again, this is wrong. So in order to prepare this talk, I did a survey regarding the other thing. Is microservices destiny? Do you have to convert your monoliths into microservices? Actually, do you think one day the world will be composed with pure microservices? No. Actually, according to the survey, a lot of people are saying, actually, I'm happy with monoliths. I don't want to change to microservices. I think it's if you create a greenfield application, first you think about microservices. And however, if you have a really good application already now, you do not need to if you don't have problems, don't create a problem. You only thinking about microservices because your monolith is too big. You want to scale a part of them. At this time, you might think about microservices. The third myth about microservices. So it's microservices making developer job easier. I think it's again the other thing is kind of people talk about microservices said, if you adopt microservices, you don't need to work so hard. That's wrong. The other thing is myth is kind of microservices increase productivity, and people saying, okay, so it's the team is underperformed, maybe because they are doing monoliths, not microservices. Again, that's wrong. And this is the fourth bullet point, microservices are fast. This, again, is quite wrong. If your application is very slow, you need to look at why it is slow. Is that connecting to database is too slow, or your runtime is too slow? You need to think about identify the root cause. If you directly migrate a monolith to microservice, maybe you will end up with more problems. Maybe you create a distributed monolith, and you have more problems, and your application is even slower. So again, actually, this is before the COVID. Actually, I did a talk at Qcon London, and there's another company called Segment. They did a talk about a microservice. They did a talk is 2 microservices and back again. So basically, they share their true story. Their company directly migrates a monolith to microservices, and then they found out that their performance actually dropped, and they are not moving on. And then eventually, they merged all the microservices together and into monoliths again. And then they found that that's a better architecture for them. And the other thing is, when I did the survey, and a very well-known person, Adam Bain, also commented, and there's some circumstances you might wish to merge a lot of microservices together into an application, and then give a file name, and then this is the problem solved. Okay, that's a myth about microservices. Let's look at the fact microservice. So the fact one is what is microservice is trying to cover. Actually, microservice is encourage independent deployment. Is one microservice should be able to release at any given time. Is without a need to worry about others. The other thing is once you adopt a microservice, you need to have a CI/CD pipeline. If you don't have any setup, then no point for microservice. If you only release once a year or twice a year, I think all the effort you put in microservice is a waste time. So you must have the CI/CD pipeline set up for that. Again, I want to stress this again, is microservice owned by a small team. Don't multiple team own one microservice, that's the wrong architecture. The other fact, microservice is no code sharing. If you think, okay, in the past, I have one common class and then this shared library used by many applications. How can I make this work in microservices? Actually, if you want to reuse the same class, you have to duplicate a class in the microservice, because your microservice is independent. You should not depend on the other microservice in order to do future releases. So this is a common fact. You need to think about no code sharing. The reason is for no code sharing is because it needs to independently releasable. If you share a common code, if you need to update that common code to be able to release your microservice, that's again wrong architecture. The second one, the no database sharing. One thing is you must remember, if you have one microservice, you have a dedicated database for your microservice. So this is so this is why later on we'll touch on why is sometimes if you want to migrate your monolith into microservices, you need to use some AI technology to identify, enter from the data point to see, okay, so this portion just use this kind of database, and then you just cut the boundary from that database point of view. The third fact about microservice is language agnostic. Microservice is not reserved for Java. You can do microservice in Go, in Python, and in Node if you want. So this is another thing. So the microservice is just like the theory, and in different applications, in different languages, you can have different APIs to help you to implement microservices. Obviously, if you use Java, Java has very rich APIs for doing microservices. Okay, I think from up to now, you know some facts and you know some myths about microservices. If you decided, I have looked at my monolith and I identified this problem should be resolved by microservices. What do I need to know? Let's have a look. The first thing, you need to ask yourself again, or challenge your coworkers. Is microservice a default answer for your problems? And if you have a problem, it's that, okay, people saying, your coworkers say, oh, we should go to microservices. You have to ask why. Sometimes it's kind of the microservice is not the right answer for that. The other thing, if you do decide to adopt a microservice, you need to understand the architecture. You need a very good architecture to go with it. So for microservice architecture, so have you all heard the DDD? Yeah, design-driven development. So it's domain-driven design, domain-driven design. So this is really kind of well-recognized design. However, for the DDD, it's still very complicated. Actually, I listened to a podcast about the DDD. Is the author about DDD actually saying DDD actually itself is really powerful. However, not many people can do it right. So it's quite complicated for DDD. And sometimes if you adopt a DDD, and also sometimes you also are tempted to use EDD, event-driven design as well. So it's sometimes you need both together. So DDD plus EDD. So the second one is you also need to pay more attention about day 2 operation. So I mentioned earlier, if you adopt a microservice, you need to have a really good CI/CD pipeline. And the operation bit is really, really important. If something goes wrong, it's not about, if you previously you use monoliths, you know exactly how the things wire up. In microservices, maybe you involved 10, 20 microservices. If you don't have a good day 2 operation, is if something goes wrong and you might be on your own. The next one is standard. You should use a standard programming model to interact with other services. And later on, we'll touch on the standard interaction models such as microprofile, REST client, and etc. to do the interaction. Or you can use a reactive messaging or sending over using a messaging format. And the next one is kind of, if you do adopt a microservice architecture, you also need to think about your team culture. So reorganize the team size, and some team you might need to move around, and some people maybe they manage the same microservice, and maybe they become a small team. The final one is be mindful on the refactoring monoliths to microservices. At this point, if you want to migrate your monoliths to microservices, I mentioned earlier there's no database sharing. You should enter from a data point of view. And luckily, IBM, there's a product called mono to macro. So you can play with it. Just Google search mono to macro. You can see how it works using AI technology. Basically, it's analyze your data, I mean, the request and response and etc. And then eventually they come up with a diagram to tell you how to divide your monoliths into microservices. Again, I did a survey here and regarding DDD and EDD design, domain-driven design and event-driven design. So as you can see, a lot of people does use a good architecture model, but there's about 18% is no pattern used. I think in a few years' time, all these microservices maybe we'll have to merge back in again into monoliths if you don't use any pattern, and down the road you will have problems. Let's have a quick look about domain-driven design. Domain-driven design basically is tell you how to divide your application into microservices. So basically, you need to draw a boundary. So it's your company is doing some operations. You need to draw a diagram of how the data flows, and then eventually you just box things up. So this is doing one thing, this one doing another thing. And then it's kind of this will become one microservice, this will become a second microservice. So it's all this diagram, and it's called the bound context. So you can look at Martin Fuller's blog and find more about DDD. So for the EDD, obviously it has event-driven design. So the microservice communicate with each other via the messaging. So there will be a messaging broker. So it's if you do like create a loosely coupled microservices, and if you use the Kafka in like as the transfer the data and etc., this design is you should consider. Like in the past 10 years, back to now, people made a mistake, and then they recover from a mistake, and eventually people realized monoliths and microservice will coexist. And this is a fact. It's not, you will not just have a pure microservice in your org, unless you just like a new startup. Everything from ground up, maybe you do microservice from day one. But if you already have some monoliths, it's monoliths are going to stay for a long, long time or forever. Actually, either monolith or microservice is not what you are trying to achieve. What you are trying to achieve is to make sure your application is cloud native. One thing for sure, I think in the next 20 years' time, and things will move gradually to the cloud. So who else are doing cloud, using cloud? Okay, great. And gradually, if we ask the same question again in 5 years' time, most of things will be cloud. I think it's 90% the application will be on the cloud, either on-prem or the public cloud. With that, you need to bear in mind, you need to create an application which is native to the cloud. So it's called cloud native application. What are cloud native applications? First thing, if you're in the cloud, again, the communication pattern, either via messages or via HTTP. It's two things. So it's very common. I think now the majority of them is still REST. So this use REST and transfer the data via HTTP. The other thing is you also need to look at the best practices. Have you heard of the 12-factor app? 12-factor app? Okay, so that's the best practices to create cloud native applications. So the one factor is about externalize your configuration. So for this one, it's because it's want to put the configuration in the cloud it's external to your application. In this case, if you change the value of the configuration, your application do not need to be redeployed. You can see the changes, you can get the configuration value straight away. And also, because once you deploy your application to the cloud, and there's a lot different external factors to influence your microservices. You need to make sure you can deal with any kind of faults. If something done, like a backend is not working, you should still return a good response to your customers. Such as, if your database is in the maintenance, your banking software, and you should return maybe the cached information to your client. I hate the banking application. Like you log on like midnight, you think, oh, suddenly realize, oh, I'm on overdraft. I really want to know what's my balance today. It's not, acceptable. It's saying, oh, my database is migrating, and you are not allowed to check your balance. It's really, really bad. I will feel better if you say, oh, up to this point in time, your balance is this. That's give me a reassurance. I know, okay, I'm not overdraft. I don't get fined. So this is kind of the why you always need to think about create a resilient microservices. The next one, if you have 10 microservices to manage, you can run out of the memories about, okay, microservice A is doing this and B is doing that. The microservice itself should have a name tag, right? So this is it should be documentable. So it's, and then in return can be discovered. And then the next one is you should always secure your microservices to prevent from unauthorized request. access. The next one is if something goes wrong, you should immediately find out, oh, red blob, that microservice is not working. So this is a good architecture for cloud-native applications. And then finally, these cloud-native applications should be intelligent. Basically, it can speak for itself. It can tell, like a cloud infrastructure, hey, I'm ready, route a request to me. Or you can say, okay, no, I'm running out of memory. Please destroy me, create a new clone for me. So this is kind of the, able to communicate with the cloud infrastructure. So this is cloud-native applications. You are thinking of cloud-native applications and think all the requirements needed for create a cloud-native applications. That's a very daunting task. However, good news is we have really good cloud-native APIs, Microprofile and Jakarta EE. Who knows Microprofile? Okay, if you do not know Microprofile, log online, go to YouTube. I have done a lot of YouTube videos about Microprofile. Actually, I done one talk this morning, a virtual talk, is on Microprofile. And the other one is Jakarta EE. Who knows Jakarta EE? Can you show hands? Okay, not many people. Who knows Java EE? Java EE? If you know Java EE, you already know Jakarta EE. This is just a name change. You know, the Java EE was under Oracle's governance, and then because Microprofile was influenced, and Java EE rehomed to Eclipse Foundation in 2017. Because of copyright or the license, they have to rename. So they are not allowed to use Java anymore. So they have to come up with a new name. So that's why it's called Jakarta EE. Log on to the jakartaee.io and find out more. Because, later on we'll talk a little bit more about Jakarta EE. And then with these APIs, obviously this is just API. You need the implementation. Luckily, we have a lot of implementations for you. Like OpenLiberty, I mentioned many times, is an awesome open source project. And I will do a quick demo in a minute to see. And also it's WebSphere Liberty. This WebSphere Liberty directly embrace OpenLiberty, add a few more features. And then is Red Hat has a Wildfly, and Payara has a Payara. This is Fujitsu has Apache Launcher. Red Hat have Quarkus. This is Kumaluzi EE from a different company, open source project. And then Oracle has Halidon. So they all support Microprofile, and some of them support some portion of Jakarta EE. However, Liberty, Wildfly, Payara, and support both Microprofile and Jakarta. So it's, have you been to today's talk on Jakarta EE? Anybody? Okay, no. I think if I give a talk on Jakarta EE, you can watch YouTube, watch the video and find out more about Jakarta EE. Jakarta EE 10 was just released on the 22nd of September. It's still hot. And this is what technology is in the Jakarta EE 10 platform. You can see EJB here in this Jakarta EE 10 platform. And then there's another release is Jakarta EE 10 web profile, which is a subset of the platform release. So this is a commonly used technology grouped together become a web profile. And even more, and this year we have a new profile called Jakarta EE 10 core profile. So this has these 7 specs, and JAX-RS, JSON-P, JSON-B, and annotation and interceptor and dependency injection and CDI Lite. Who else knows CDI? CDI, context and dependency injection. Okay, if you do not know CDI, again, please take a look at later on, like Open Liberty IO has a really nice guide on how to use the CDI. So this is the architecture about use water APIs to build cloud native applications. For the core, create cloud native applications, you use config, Jconf core profile, and also this REST client to link the cloud native applications together. And then this query language, and this is if you use messaging for the communication, you will use React messaging. So this you can plug in Kafka in. And also this for OpenAPI for documenting, and this is for creating resilient microservices, and this is for secure your cloud native applications. And then this is observability, use telemetry, microprofile telemetry, microprofile health, and microprofile metrics. Cloud native application by name means working natively in the cloud. So basically, it's built for the cloud. Up to now, we say, okay, we use Java and create use a lot of microprofile APIs, Jconf APIs. Eventually, you have a lot of classes, right? A lot of classes. Now, how can you move to the cloud? How can you deploy to the cloud? First thing, obviously, you put all the classes together, compile them, containerize them. For the containerization technology, you will need a Podman and or the Docker. And anybody know Docker? Yeah, great. Anybody know Podman? Yeah, I think it's if you do not know Podman, I think it's because of Docker, because the license and also the no longer free and etc. And people moving up to Podman. So it's you might want to learn about Podman. And then the cloud native application deployment, and could it be either on-prem or public cloud or hybrid cloud? So hybrid, some of them on the on-prem, others in the public cloud. So this is a hybrid cloud is going to be the future. Exactly, now the companies, I mean, you watch the news, merging, and also the companies split up. So it's going to be like a hybrid cloud is going to be the future. Okay, I will do a quick demo about how can you start to create your cloud native applications. So I go to So luckily, in Open Liberty, we have a starter. It's called Open Liberty starter.openliberty.io. So the beauty with this is the web-based based starter. So you can see as is Jconf. And you can see the Java SE version 8, 11, or 17. I can choose 17. And then here you can choose latest version 9.1 and microprofile 5. You just say generate a project, and then it's create a zip. I create a Maven. And if you are, who is using Maven at the moment? Maven? Gradle? Gradle? Wow. Gradle is more. Okay, that's interesting to know. Yeah, we have both. So, and then I unzip it, and I can go to a terminal, hit bigger. So I use my IDE, for example, I use the VS Code. Anybody use the VS Code? Okay, good. IntelliJ? Okay. Eclipse IDE? Okay. Looks like IntelliJ and VS Code are quite popular. So here, you can see here, you create a class, a Java class. This is the REST, application, and then deploy to Liberty. and you can see here the POM. We will see the beauty of it. All the Jconf APIs and microprofile APIs available to you. I quickly show you something. If I say hello, and then I can just create the for example, Jconf resources. I will see that. And maybe here I just say string, say hello. I can return hello Jconf. And then, I'm creating the RESTful cloud native applications. And here I will just say, give it a path. Hello. And this is a get operation. HTTP cat. So it's in there, and then I can just start this in the dev mode. So this is Liberty dev mode. So it's, let's have a look. And then it's install the feature and etc. And eventually you can access the backend. While it's doing that, let's quickly go back to to here. And then we can go back you can go back in a minute to see the result. But consider the time and etc. Let's move on. So in the future, we talk about the cloud native application, and nowadays is serverless, right? Is very. Have you heard of serverless? Is very dominating at the moment. And people started talking about, okay, we need to rush into a new era of serverless. And then people already starting asking, is microservice going to be obsolete for serverless? If it's in the future, it's just one class, and then you run as functions. What's the answer for that? Let's first find out what is serverless. Is serverless going to be no server? Is no server in serverless? Do you think so? Anybody? Actually, no. Serverless means it has a server, but server is too simple. Like OpenLiberty, too simple. You don't need to worry about it. The other thing, serverless is for public cloud. If you have on-prem, you have everything. You bought everything. Why you should pay the rent? If you live in your own house, why do you need to pay the rent? So it's serverless directly pay as you go. Basically, it's only applicable to public cloud. For example, you're renting stuff. That's what serverless is for. Again, serverless is not for all kinds of applications. Serverless is only suitable for the application which is run occasionally. Maybe one day only run like a few minutes or 20 minutes or something like that. It's only live for a short period of time. So this is what is suitable for serverless. And then serverless need to be really fast. Considering that, if you have a serverless, if you only live for like 2 minutes, if you need to start in 2 minutes and then die in 2 minutes, that's defeat the purpose. It's like a start up 2 minutes and then live for 2 minutes and then die in 2 minutes. Actually, you pay the 3 times the more money for this serverless architecture. So it's a must have a fast startup. And when you mention about fast startup, you immediately might think about GraalVM. Have you all heard of GraalVM? Okay, so however, GraalVM is not the only solution for the fast startup. There's a new technology. It's called, basically it's a Linux, in the Linux kernel. It's called check install. So it's a CRAU. At the moment, OpenGNI and actually utilize this Linux CRAU. So we have a new feature called Instant On. So OpenGNI has this support. Also, OpenLiberty currently is having this initiative, a project, OpenLiberty Instant On. So OpenLiberty is your application, your cloud native application on. This is OpenLiberty Instant On. It can start up within 100 milliseconds. Sometimes it's 70 milliseconds. It's really, really fast. However, this big advantage over GraalVM is that GraalVM is build-time compilation. So with build-time compilation, basically all the things are sealed up. If something goes wrong, you cannot peek into it. With this CRAU, basically like a GVM, it's running as normal. So you can still plug in all the analytics tools. It still works. So this is a great technology. So check it out. We are going to have a blog on openliberty.io. Follow me on Twitter, and I will publish the blog when it's ready, so in the next few days. Again, so I mentioned that serverless is only suitable for public cloud. At the moment, a lot of public cloud has this capability, like IBM Cloud Code Engine, Amazon Lambda, and Google Function. They can all support this a serverless pattern. So, in summary, cloud-native application won't be obsolete when serverless arrive. So a few takeaways is do not use microservices as a goal, and look at your problem and first. And monolith is not evil. And sometimes you have every good reason to use monolith. Use best practice when you need to do microservices. And again, remember, it's completely normal. You have microservice or you have monolith. Remember, you need to create cloud-native applications. Again, cloud-native applications support serverless, so don't need to worry about that. Even though the new serverless era arrives, and you stay put with your cloud-native applications. So below is useful resources. If you don't know MicroProfile.ee, log on to this link. And also, if you want to know this technology, go to openliberty.io/guide. So with that, if you want to know more about MicroProfile, and you can purchase a copy of my book. Yesterday, we had a book assigned and give away few free copies. Any of you got a free copy? Okay, brilliant. Hope you enjoy this book. I would love to hear feedback from you. If you haven't, I'm so sorry, we ran out the book. So you can get one copy from Amazon. Maybe in the next conferences, we can get more books. Okay, with that, I think because, I'm pretty much running out of time, let me quickly go in here. So my application, if I say localhost 9080 OpenAPI. So you can see I have an endpoint, the Swagger. If I do UI, you can see here what I created. And if you do a get operation, and you can evoke it, try it out, and execute. And because I didn't specify the medium type, so I can say download the file is downloaded. It said hello Jconf. Yeah, it's all working. So just within 1 minute, I create cloud-native applications. Okay, with that, thank you so much for coming to my talk, and I hope you found it useful, and get in touch if you need any more information. Thank you.